Good morning, all. We are starting our next session on various topics in the areas of health, safety, security, and environment. On the stage, I have with me Mr. Ananta Bhende, who's a DGM Fire and Safety from Indian Oil Corporation. Then next is Ms. Monika Choudhary, a Superintending Chemist from Oil and Natural Gas Corporation Limited. The next is Mr. Maddala Devarayalu. He is a Joint Director from OISD. Next to him is Mr. Dinesh Brahma from the Power and Utility Department of Numaligarh Refinery Limited. And the last speaker is Mr. Shathish Kumar, again a Joint Director from OISD. Now I would like to ask Mr. Ananta for his presentation.
Good morning to all the delegates and the audience. So now in the last 1.5 hour, we are bombarding with the various safety, HSE and innovations. So we'll start with some Sanskrit mantra. Sarva bhavantu sukhina, sarva santu niramaya, sarva bhadrani pashyantu, ma kashid with Om Shanti Shanti Shanti. It means, may all beings be happy, may all be free from illness, may all see what is auspicious, that is good, and may no one suffer from sorrow. So this is the thing. So we are here to present, and my topic today is the vertigo testing model for ensuring the working at height and to prevent fall from the height person due to the acrophobia. Since you are aware that the human being is the biggest asset for all of us, because if any machinery is getting damaged or in the fault, then you can buy that. But the person, if something happened wrong, then nobody can be buy this one. So looking to that, this model is being developed. And as we are aware, as per the Dr. S. Radhakrishnan ji, the preventable accident, if not prevented due to our negligence, so it is nothing but the cold short of murder. So it is the thing. So why we need the vertigo testing model? Since we are aware, we all are doing the work in the industries and we have a lot of experience. So we found that the person, the contractor workers, which is very, we can say, the person who is not aware about the hazards in the industries, specifically in the petroleum refining industries. And if we deploy that guy without giving the proper training and proper awareness, so then there may be the what I shown you the previous slide. It is nothing but the cold-blooded murder. So that's why this I thought, and this vertigo testing model come in my mind, and I developed this for identifying the individuals with the acrophobia or balances issues and building the safety culture among the industrial areas. This enhancing the confidence, and this test can be build the confidence for the supervisors as well as workers, that individual on site, and they are medically fit for their jobs, reducing the accident by ensuring the right person to assign the right job. If he's having the experience and if he's having the very good knowledge on that, then he can do perform the job in a very better manner and give the efficient work. Promoting a positive work culture, environment, identifying and addressing the vertigo that can lead the more positive and satisfied workforce results. What is the objective of this work, or what is the objective of this vertigo testing model? in oil refineries, one of the critical job is working at height. And so far, if we go for the statistics, we found that most of the incident which has happened due to the fall from the height. Because people are not aware whether they are having their some BP issues or they have some other nystagmus issues or some other related issues. We simply deploy the person in the job and the person who was working at height and he's having some, let's say suppose vertigo or some epilepsy, and he is not aware, then there might be a chance that the incident may took place. So, due to this, these are the objective of the work. Even after the medical fitness test, accident take place by fall from the height due to the height sickness as a personal factor. What we found, they have their medical test certificate they bought from the outside, but we don't know whether they have conducted something, some test, vertigo test or not. So for that ensurement, we develop this vertigo testing model and we do for each and every employee and contractor worker at our site, so that the person, those who are having the vertigo problem or acrophobia issue, they cannot be allowed to work at height. And this task observation done and feedback taken from the field, we are doing the various trials and errors methods. And after that, trials and errors, we found that this model worked efficiently for the person, those who are involving in the working at height job. And there are certain references also mentioned in the subsequent slides. These are the experimental details. This model is being used for the doing vertigo for the workmen as well as the employee, the person, those who are involving in the working at height job. The workers engaged in the projects, mainly in the shutdown, maintenance, carry the many critical routine activities at height, which exposes the worker to fall from the height. During such time, this model found very effectively and helpful to check the medical fitness of the worker for free from the height phobia. If the workman fall from the height, the test and doctor certified that he is not medically fit for the working at height, then will not allow that person to do the job at working at height. These are the certain medical parameters which are referred here. Like we have our dedicated first aid center in which the doctor is there, and we have finalized certain parameter like a BP, SpO2, then your pulse rate, then nystagmus test, and all other as per the doctor advice. This we have conducted rigorously for each and every contract workers, apart from whether he is involving in the high job or not, because we don't want to take any chances to for any incidents. We have also developed the SOP, Standard Operating Procedure, for the vertigo test of working at height. We have certain criteria as per the doctor advice, like SpO2, what is the range of that SpO2, it is greater than 95%. Then your BP range, what is the BP range? And the activity that we conduct here, the person, those who are indulging in the working at height job, we have to first check all the parameters which is mentioned as per the doctor requirement. And after that, we have a model that what you have seen here in the pictures. We have 5 meter by 5 meter, this height is the 5 meter, and the channel we have provided, and that the person has to and fro from that beam ISMB channel, 200 ISMB channel. And after that, the same parameter, when he come down, the same parameter will be noted down again. If we found that the parameters are mismatched, or if it is not within the range of what the doctor prescribed, then we are never allowed that guy for working at the job. But the person, those who are fit for the job, then for the entity or for the identity, we provide the hologram of V sticker on their gate passes so that one can easily identify the person who is fit for the working at height job. These are the benefits that we are getting from this. The safety confidence building in the supervisor and the engineers and the stakeholders. We do these tests for our, specifically the inspection engineers and the other, those who are involved, particularly in mechanical and other guys, for those who are engaged in the vertigo, height, or acrophobia, or working at height job. The only thing is that the person has to very clever and he has to tell us, or doctor, that he is suffering from what is called that your acrophobia. Then only the person can be saved. Otherwise, if suppose he is hiding something, then the person is very difficult to identify what the past history of that particular person. The worker actually come to know about their ability and inability for height work and remain alert in the future jobs. The person can take medical treatment for deficiencies and remain healthy and safe. So we have a procedure. If a person is having some BP related issues, then doctor advise them for the medicine of a BP, and after the 1 week, the person can call again for the review. And if all the parameters if found within the range, then person can be allowed for the working height job. But if the person is found the same parameter or the BP will not within the specified range, the SpO2 is not within the specified range, then that person will not allowed for the working height job because he is suffering from the acrophobia. That's why that person cannot be allowed for the working height job. Then the person that can be can taken the medical treatment or for deficiency, that's what I have told, can be deployed in other job which is suitably for him. Means we cannot deny or we cannot take him out. We can deploy them for the lower job, and we take one undertaking from them that he is suffering from acrophobia or vertigo, and if something went wrong when he is supposed to do the work, because there are suppose n number of contract workers are working. Since we have the project, so many projects are going on in the refineries. So there are chance we cannot see each and every person go and here and there because 10,000 contract workers are working. So we take the undertaking from them that he is suffering from the acrophobia, and if something went wrong, then he is held responsible for that. Then selecting the right person for the right job. In nutshells, the avoidance of fall from the height due to the poor health and achieving the zero accidents. It's low-cost system designed within the refinery. This is an in-house development and sense of satisfaction and positivity among the workers, enhancement of the safety culture among the contract workers, and developing the behavioral change among the contract workers. This is the quantitative result what we are found, and we gathered the statistics analysis from the January 2020 to 25. We found that it is drastically reduced. The person earlier the fall rate was, and the person those who are having, they are not aware about their deficiency. So after this test, the graph is suddenly going down and it get the improvement. And that's why this vertigo testing model is quite helpful for getting the right person for the right job. These are some results and discussions. So by conducting this vertigo test, it is known and confirmed the workman capabilities in terms of the height phobia, which is very important to avoid any untoward incidents. Immediate fitness check prior to deploy in the critical working right job. Proactive system of safety awareness for worker engaged in the project shutdown and maintenance, etc. activities. During the vertigo test, before and after checking and medical parameters like BP, SpO2, as I told earlier. During the testing, if the doctor declare the unfit for working at job, they eliminate the people and act as the doctor advice. All the contract workers, they are not familiar with such type of critical jobs, and this will help for betterness of their particular contact person, those who are having the acrophobia or working at phobia. By conducting these tests, the right person will choose for the right job, which enhance the safety among the contractor workers, as well eliminating the fall from the height, and which also improve their own. This vertigo test model help also the personnel of working of job. This is also appreciated by the government of Gujarat. And you can see in the Google, you find that the paper is published on this acrophobia. And these are some references that we have taken. Thank you very much.
Okay, next we are taking is Dr. Maddala Devarayalu, Joint Director from OISD. He'll be talking about process safety insights from 2 fatal refinery accidents.
Very good afternoon to all. Today I'm going to share 2 important incidents which happened in the recent past. Uh, uh, these 2 incidents happened in 2 major refineries. This brings to the fact that how we are ignoring some inherent hazards, inherent risks existing in the refinery, which we are routinely undertaking some activities. So before moving into the presentation, let me brief about the organization which I am working. Uh, it's Oil Industry Safety Directorate. Oil Industry Safety Directorate was established in the year 1986, and it's a technical directorate under the Ministry of Petroleum and Natural Gas. The primary objective of Oil Industry Safety Directorate is enhancing safety in the entire spectrum of oil and gas industry in India. So this can be achieved by implementing a series of self-regulatory measures aimed at enhancing the overall safety of the industry. Uh, we do develop the standards we will formulate, and we also revise oil industry safety directorate standards of approximately close to around 110 standards. So whenever the requirement arises, we formulate new standards, and we do revise the existing standards also. Apart from this, we do ensure whether these standards are in compliant to the requirements by auditing the facilities as per the requirement of every 3 years. And we do conduct the pre-commissioning audits also, ensuring all these things are in line with the required standards. One of the most important activity we do undergo is accident investigation. We do conduct the accident investigations for major incidents only. So the overall objective of oil industry safety directorate is to have, enhancing safety. Apart from this, we do share knowledge sharing in different forums by, industry-wide learning and knowledge exchange by conducting webinars, some online sessions as well. So the case studies I am discussing in this particular session, one is related to a benzene storage tank explosion involving a hydrocarbon which is highly flammable, carcinogenic. And the second one I am discussing is about the toxic hazards, the hydrogen sulfide exposure in slop tank in one of the major refinery. So coming to the matter, why this case study plays an important role at this forum. So these actually catastrophic incidents do not occur, in a single go. These will be, these incidents do happen when engineering safeguards are not reinforced by procedural, the robust procedures, hazard awareness, and a strong safety culture. So this reveals, whenever these incidents these incidents happen, it significantly reveals what are the systemic, flaws, weaknesses existing in your system, whether the hazard identification is being assessed, design integrity issues, and the most important is the safety culture you are practicing in your entirety. So the overlooked routine deviations, these will progressively align, as you know, the Swiss cheese model. So these will align, and only then and only the catastrophic accident do happen. So the study concludes with key preventive insights and process safety perspectives. Uh, One of the important theme by this session, it reinforces one important aspect, that compliance does not automatically translate into safety. Yes, coming to the case study, first case study I am discussing, it's about the explosion and fire in benzene storage tank. Let me give a brief about the incident. And this entity is storing benzene as a feedstock for one of its downstream units. And this benzene is being imported through tank trucks, and this is being transferred to a storage tank, from where the stored benzene is further transferred to its downstream units. So on the day of the fateful incident, uh, and there is a routine practice of sampling activity from the storage tank to ensure the quality requirements, as quality plays a quite important role for its downstream units. So this incident happened during the sampling activity. The sampling activity is being conducted at the top of an internal floating roof type tank. So benzene was transferred to the said storage tank, and sampling activity was to be commenced, and subsequently explosion and fire occurred in the tank, and the frangible roof got exploded. The sampler was impacted, and the roof got landed approximately 20 meters outside the dike. So firefighting operations were initiated. 9 tanks were existing within the dike, and after approximately 5 hours later on, uh, though the firefighting operations are underway, one of the adjacent tanks again caught fire, exploded. The roof of this particular tank, it fled away approximately 160 meters away from the dike. And the second tank roof was propelled 160 meters away from the tank. Injuries occurred to 2 persons and an employee, and the 2 persons got succumbed later on. The incident was fully controlled after 10 hours with extensive mutual aid fire support. You can imagine, more than 55 fire tenders, 10 hours of firefighting with extensive mutual aid support. The fire got controlled after 10 hours. We will go into the major observations and recommendations of this particular incident. The major observations found by the investigating team. This sampling, the standard operating procedure did not specify any kind of relaxation time. Relaxation time is quite important, particularly for low conductivity fluids. You need to allow the contents to allow certain time, which is called as relaxation time, so that the conductivity, conductivity remains. Uh, Conductive sampling, stainless steel cage with non-conductive rope was used in this particular sampling purpose, which violated the requirements of recommended practices of static electricity. Inert gas blanketing was not provided, and the dip hatch cover was not provided with any kind of non-sparking proof, or it's not of non-sparking time. Again, the deviations of 108. Tank resistance measurement was in due, so it was not sure that that thing was intact or not. Layout deficiencies existed, and we have reported in previous audits as well. Uh, pool fire resurgence and escalation, particularly near the second tank, triggered for the second explosion. And there is no documented training or competency criteria for the samplers who are regularly collecting the samples from the tank. So overall, the hazard awareness is not up to the mark, and the periodic inspection of the internal floating roof tank was not in practice in this particular entity. So the investigation, after thorough investigation team, after thorough review of all the causes, we have come into the conclusion that the first explosion was caused by confined vapor cloud explosion between the tank roof and the internal floating roof. The cause for the spark could be most likely one is the static spark generated at the hatch cover, or the spark, the discharge of static electricity in between these fixed roof and the internal floating roof. The second explosion, it was occurred due to the boiling of material aggravated during the foam application interruption at the incident site. These are the major recommendations we have proposed. You have to take alternate sampling, not from the tank top, ensure the non-sparking type hatch covers. Gap analysis should be carried out for 118 deviations, and nitrogen blanketing for all internal floating roof tanks handling similar products. Inspection procedures for internal floating roof tanks. There are clear guidelines how to inspect your internal floating roof, and strengthening contract management. The other important major recommendations, yes. So the primary reason for static electricity, how you can prevent the static hazards, because these are to some extent ignored area. So you need to have, you need to identify the risks associated in your daily sampling activities and identify the inherent hazards. So these are some of the recommendations. You can prevent the static hazards. I will move into the second case study as the time is short. So this one is the toxic exposure in one of the slop tank in one of the major refinery. Coming to the brief of this incident, an operator was informed to inspect the roof of a slop tank for suspected rainwater accumulation. This incident happened on the external floating roof tank. So the loss of contact prompted the deployment of a second operator to find the whereabouts of the first operator, who was sent to the tank top. The second operator reported the first operator collapsed on the floating roof deck, and subsequently the second person also attempted to rescue the fellow colleague. So a third operator reached the tank top and found both these operators were found lying unconscious on the roof deck. So emergency assistance was mobilized. Both operators were rescued and shifted for first aid treatment. But unfortunately, both were declared dead. So what caused the persons to go onto the floating roof deck? So it was clear that one cannot enter onto a floating roof deck when the roof of the tank is below 3-meter mark from the top. It was clear that you need to enter only by taking a confined space entry permit, because this is considered as entering onto a roof, entering onto the floating roof when it is at such a lower height. It is considered as a confined space. So there are clear guidelines in the OSD standards, what PP is required, what are the conditions to be met before anyone entering the floating roof. So these are clear violations of all these guidelines. So why this happened is it was post turnaround. So the intermediate streams have been likely routed to slop tank, and there was a heavy rainfall before the night of that incident, and it was a perception that there are cases previously also defloating of the roof. So the person was sent to the top of the tank to inspect whether the floating roof is intact or not, as they have observed some kind of fluctuations in the level transmitters. So thing is that there are no H2S monitors, there is no PPE compliance. Tank was not designed for SOAR low flash point service as well, and history of wet H2S corrosion as well. The metallurgy upgradation deferred by the inspection was ignored. Instead, an alternate of epoxy lining was done. So these are the other major observations. Emergency roof drains of single deck, these were not removed. The guideline says that you cannot have emergency roof drains for single deck external floating roof tanks. So the root cause is fatalities was acute inhalation of toxic gas at concentrations above IDLH values. The injured person had entered the confined space entry without necessary permits, and these are the multiple barriers which got defeated. So these are the major recommendations we have proposed. And as you can see, both these incidents will to some extent similar in nature. As you know from the Swiss cheese model, all these barriers got defeated and got aligned, and then only the catastrophic incident happens. So I hope these two incidents will convey one thing, that instead of going for compliance-based approach, one needs to have a resilience-based approach. Thank you, one and all.
Thank you, Doctor. From these two incidents which Doctor has shared, two key points which can be taken away by everyone is we should not lose sight of the static electricity being generated during various activities when we are dealing with the hydrocarbons. And second one is not to be casual about the H2S presence in wherever we are likely to have the H2S being generated as part of our operations or storage. Now next we are taking Mr. Dinesh Brahma from the Power and Utilities segment of Numaligarh Refinery. He'll be sharing his valuable experiences and learnings from rare and unsafe and hazardous fire incidents in the Power and Utilities sections of NRL.
Very good afternoon to all present here, respected chairperson and my fellow co-speakers and all the audience. Today I'm here to present a paper on a title, Invisible Hazards and Visible Lessons. It is rare fire incidents where we have experience in our refinery, and this are being authored by three persons, Shathish Kumar Bora, secondly Hidaranjan Kalita, and myself, Dinesh Brahma. So let's begin the slide. So the abstract goes, in our power and utility, we have experienced 4 rare cases of fire. Normally we see the fire from the diesel, petrol, LPG and all, but here we will see the 4 different cases, very, very rare and unknown cases of fire. And these incidents involve hidden ignition source, which we cannot see, but they are hidden inside the something, which we'll see in the later slides. Very interesting. And all the events are being controlled safely without any injuries. And the objective is to share the learning with you all so that it doesn't reoccur in any place. Introduction. Normally we in power and utility, we deal with high temperature, high pressure and flammable media. Secondly, rare unforeseen hazards may still occur even though we follow the SOPs. And these incidents are occurred in HRG, that is heat recovery steam generator, cooling water, natural gas, and turbine systems. So let's begin in the next slide. The first incident is the HRG2 dried insect ignition. Have you ever heard the fire from the insects? So let's begin with this story. The brief incident is that during November 2024, we have started HRG2, that is heat recovery steam generator. The startup was very, very smooth, no problem at all. We have generated a steam. But while going through the walk down checks, we have sensed some burning smell. While checking thoroughly, we have found that the superheater zone and evaporator zone, there was some burning smell. So when you open the insulation of the superheater zone, we saw some flame and smoke. And to our utter surprise, when we further open it, we saw some insects debris inside the insulation, because of which the insects got fired. Now, how the insects can lead to fire, we will see in the next slide, sir. The root cause analysis. Because when the incident occurred, we took shutdown of the HRG2, then cool down the HRG. After the sufficient cooling down, we removed all the insulations of the superheater zone, and to our surprise, it was found that at the floor there was 300 mm crack, and through that crack, the high temperature flue gas of around 430 degrees centigrade was coming out, and that flue gas came in contact with the huge lot of insects which were fallen inside the insulation. And these insects contain hydrocarbons, fats, lipids, proteins, because of which the insects got fire in contact with the high temperature flue gas. And the corrective actions we have taken is, we have the crack is sealed, housekeeping done thoroughly, insulation, earlier the insulation was open, now this insulation is being converted into box type where there is no chance of insects ingress. And secondly, thirdly, the high pressure mercury lamps. In our lighting area, we earlier used HPMPL, high pressure mercury lamps. This lamp emits UV rays, because of which the insects get attracted. Now these HPMP lamps are being replaced by the LED, where it is more efficient, no insects attraction. And the SOP, sir, we can see that organic debris can also be the flammable material. High temperature can be a source of ignition. Hidden insulation are very, very risky. We should not leave any gaps of the insulation. And LED lighting used in place of HMPL lamps. And lastly, shutdown and startup cleaning, we have very strictly monitored in every shutdown. These are the pictures, picture 1 and 2, where you can see a lot of insects which are being accumulated inside the insulation. These insects are being partially burned, some are fully burned because of high temperature flue gas contact. So this is very, very uncommon, where the insects can also lead to fire. Picture 1 and 2 are same, and picture 3 shows the long crack. The long crack where the flue gas is coming out at a high temperature, hitting the insects. And the picture number 4 shows the high pressure mercury lamp, where we can see the loss of insects are being accumulated inside the bulb casing. Picture number 5 and 6 shows the difference between the high pressure mercury lamps, where we can see a lot of insects accumulated, and the right hand side, picture 6, LED lamps where no insects. Very, very clean and more efficient. And these are the box type insulation, where insects cannot go inside nowadays. The second incident goes H2S, H2S fire in a cooling water modification. Again, the story goes, we have undertaken modification of underground to overground cooling water supply and return jobs. Cooling water supply jobs done very smoothly, no hazards, nothing. But cooling water return, what we have done, while the gas cutting was going on, we going on, but at one point of time, from the cooling water return header, as high pressure ejection of gas came out from the cooling water return header. How can it come, how the cooling water can be so dangerous? We will see in the next slide, sir. A root cause, when the cooling water return gas cutting was going on, there was some trapped H2S gas in the low-lying area. That H2S gas, upon hitting with the gas cutting, they get agitated, and when the first hole was cut with the gas cutting, that H2S gas and trapped H2S gas came out through the hole and came in contact with the oxygen and leads to the exothermic reaction. which leads to high ejection of high pressure gas. So this is the cause. And the corrective actions taken, we have again repurging of nitrogen gases done, DCP and foam sprayed, and very, very important is mud plugging. This is a very, very effective technology we have used, the mud plugging. We have, through the hole of the gas cutting portion, we have inserted soil and water mixed together and put the mud plug inside the cooling water return header. And this mud plug acts as a barrier to the trapped H2S gas, because of which no more gas was coming out of the header. And we could complete the jobs very, very safely. No more fire incidents. So this is the mud plugging beauty. Then key learnings are, we should not take the cooling water lightly, because cooling water may not be directly very dangerous, but if contaminated with the gases like H2S, it can be very, very dangerous. And the entrapped gas can remain even after the purging also. Thirdly, we should not assume that the job is safe, because every new job is a new hazard. And H2S is highly toxic and flammable. Nowadays, we go for H2S drilling on a regular basis to bring awareness. This is the picture where picture number 9 shows the overground header. It is successfully done. And the right hand side picture number 10 shows the mud plugging, very, very effectively used as a physical barrier to cut off the trapped gases from the underground headers. And the third incident is pyrophoric iron sulfide ignition. Again, the story goes, during our RTA, HRG1, the heat recovery steam generator, maintenance was going on. We had two hot jobs, one at the upstream, second at the downstream. Upstream job was done very, very smoothly, but in the downstream portion, when you open the flange, we saw a reddish color glow of the iron particles. That is pyrophoric iron. How the pyrophoric iron can occur fire, we see in the next slide. Very interesting. The root cause. The upstream job we have done very safely, because purging done, LL0, no hydrocarbon, okay, fine. But the downstream portion, where the low-lying areas, the hydrogen H2S get accumulated, the rusting of the iron get accumulated. When the flange was open, it exposed to oxygen and leads to pyrophoric iron fire. So this is the cause leading to the fire incident. Corrective actions taken, we have stopped all the jobs. Again, repurging done, LEL check, done safely. And the key learnings are, even though the nitrogen purging is done, we cannot ensure 100% that there may be no trapped gases. Very, very important to take double check or triple check. And never assume the equipment is safe on the earlier jobs. Every job is a new hazard. And the pyrophoric iron is very spontaneous. Do not take it lightly. And keep the H2S weight so that it doesn't escalate. And thirdly, non-sparking tools are obviously used to clean the iron particles. So this is the picture here. Picture number 11 shows the flange which is open, led to the exothermic pyrophoric fire. And picture number 12 shows the samples where the reddish glow observed due to the oxidation of the FES. And fourth incident is also very interesting. Turbine lube soaked insulation. The story goes, the turbine had lube leakage from the non-Dravian bearing housing. The leakage was very, very minor and very in initial stage. But with few days in time, the lube oil got soaked inside the insulation, and that insulation act as a storehouse of the lube oil. And that lube oil came in contact with the hot surface of the turbine, which was at temperature around 300 plus. And the lube oil we used was Hydrol 68. Hydrol 68 has temperature, a flash point of 238 degrees centigrade, and the turbine casing has temperature of around 300 plus, because of which the flash point got crossed, the lube oil got fired, there was a fire in the turbine. This is the incident. The root cause is the coming in contact of the low boil in contact with the high temperature turbine casing, leading to the flashpoint crossover, leading to the fire. And corrective actions taken, we have started the standby cooling water pump, DCP was sprayed, and fire was contained very effectively. Key learnings: low boil soaked insulation can also be a source of fire. Insulation can lead to accumulation, reservoir, and we should not leave the leakages. Even if the leakage is very, very minor, we should arrest it at the right time. And other housekeeping is also very important. Additionally, these are the pictures here. The fire occurred in the turbine casing here, in the low boil non-driven bearing side. And after thorough checking, we found that because of timely actions, there was no damage to the turbine casing, turbine blade. The corrective actions and prompt actions help us to keep the equipment safe. The conclusions here: the fire can originate from hidden and known routine hazards. Normally, we see the fire from the normal sources, but these 4 cases shows us that the hidden and known routine can also be the hazards of fire. Sometimes SOP compliance is not at all safe, not fully fully sufficient, but we should also go for experiences-based learnings. Early detection, immediate job stoppage, and prompt actions are the key to firefighting. And these learnings strengthens, brings resilience, boost our confidence. And such rare cases may also experience in other refineries, so may be effective for you also, sir. And conclusions: the hidden hazards can also cause fires, not only the hot work. Past safe jobs do not guarantee the present safety. Organic debris, minor leaks, deposits, and insulation can also escalate silently. Procedure guidelines. Procedures guide us, but vigilance protects us. Stop, assess, wait, and verify. The steps every time we should follow. Stay alert, stay safe, and healthy. Keep on learning. Lastly, the mantra goes: small hidden hazards can cause serious fires. Vigilance, learning, and proactive actions are the strongest defenses to the invisible hazards. Thank you all, sir. Wish you all a happy new year, sir, from NIL side.
Key message is we should not lose sight of these areas which Dinesh has tried to highlight by sharing these 4 incidents. Now next we'll take a presentation from Monika Choudhary from ONGC, talking about breaking microbial resistance, innovative biocide approaches for effective GAB and SRB mitigation in oil field operations.
Good afternoon, everyone. I am Monika Choudhary, Manager Chemistry from ONGC Ahmedabad. First of all, I would like to thank my senior management for allowing me and encouraging me to present our work on the platform of IEW. So today I will be presenting our field study of breaking the microbial resistance, innovative biocide approaches for effective GAB and SRB mitigation in the oil field operation. The western onshore asset of ONGC is a mature field, and in the mature field, along with the crude oil, the production of effluent is a common phenomena. Handling of this produced water and effluent becomes critical at the for the asset. To fulfill the guidelines to protect the environment, the water cannot be discarded and left over anywhere. So it is being injected into the reservoir for the maintaining the pressure and the production. However, before injecting the water into the reservoir, there are certain parameters that needs to be within the predefined limit, and one such parameter is the bacterial growth. So this study basically covers the water treatment of produced effluent in the ETPs, that is the effluent treatment plant, WIPs, that is the water injection plant, and SPEUR pilot project, that is the surfactant polymer plant. In this study, basically, we have done the study to reduce the microbial control and to eliminate the bacterial colonization in the water treatment facilities. Now, first of all, it is essential to understand the what is the microbial growth in the microbial activity in the oil field operation. Mainly involve the two bacterial group, that is the GAB and the SRB. GAB is the general aerobic bacteria and SRB is the sulfate reducing bacteria, and coexistence of both of these bacteria in the system is the problematic. Here the GAB creates the biofilm and it is an aerobic bacteria. So for its growth, it basically consumes the oxygen and thus it creates the oxygen depleted zone, which on the other hand, the SRB, which is an anaerobic bacteria, it helps the SRB to grow rapidly. Also the SRB, it generates the sulfate, it generates the H2S through the sulfate reduction, and this generated H2S is the main problem. This causes the severe operational challenges for the assets such as the reservoir soaring, corrosion, and biofilm plugging, and it reduces the EOR efficiency if it is not controlled on the time. In ONGC, there are certain guidelines for the water injection. So the permissible limit for the GAB and SRB, which is being followed in the ONGC, is 1 to 10 multiplied by 10 to power 4 counts per ml for the GAB, and SRB shall be completely nil. However, to make the SRB completely nil, it is essential to eliminate the GAB also, as both of these bacteria help each other to grow into the system. Of course, in the system, we are using the several chemicals to control their growth. However, the conventional dosing method, that is either the usage of a single biocide or the usage or the dosing pattern, same dosing pattern for a prolonged period often fails. And why it gets failed? It is due to the adaptation and the microbial resistance. So when a bacteria is exposed with the same chemical for a longer period, it gets adapted and thus it makes the dosed chemical less effective. On the other hand, the GAB and SRB both are different bacteria, both have the different cell wall structure. So one biocide cannot effectively kill both of them. Other than this, the bacteria grow inside the biofilms, and the EPS layer, it protects the biocide to penetrate into the EPS layer. It basically blocks the biocide penetration before it reaches to the microbes. And also the oil droplets, H2S, organic matter, it also consumes the dosed biocide before it reaches to the microbes. Thus, the effectiveness of the chemical decreases with time. So as I have already explained that this study covers the water treatment in the ETP, WIP and SPEUR project. Here there are two ETPs. The produced water from the group gathering station is transferred to ETB for the treatment facilities, and then further it is transferred to water injection to inject into the reservoir. In the ETP1, we are treating approx 42,000 meter cube, and in ETP2, we are treating approx 35,000 meter cube per month effluent. After when it subsequently it is transferred to WIP1 and 2, where the water from the another resources are also being added, and we are treating approx 45,000 meter cube and 36,000 meter cube per month effluent is being treated. And for the EOR project, we are using the water to prepare the SP slug, that is the surfactant polymer slug. This SP slug is injected into the wells for the tertiary recovery of the crude oil. This slide explains the. This slide is the shows the general layout of the ETP, WIP, and the SP plant. In ETP, we are dosing the biocides before the surge tank or in the inlet of the surge tank. And in WIP, we are dosing it before the sand filters. And in the SP plant, we are dosing the biocide in the raw water tank and the polymer maturation tank to arrest the growth of microbes. So our key strategy to remove the GAB and SRB from the system was based on the three pillars. First one is we have adopted the rotational dosing strategy. As the rotational dosing strategy, it prevents the adaptation of the microbes for a particular chemical. And let us understand how does it work. So each chemical or each biocide work with a different mode of action, in terms of damaging the cell wall, denaturing the protein, and disrupting the metabolic pathways of the bacteria. Suppose one bacteria which has survived one chemical, it may remain susceptible for the another one, and thus it weakens the biofilm integrity and its protective function, as the biofilm is the main thing which protects the bacteria from the dosed biocides. With the regular dosing, we have also initiated the periodic shock dosing, as the periodic shock dosing allows the penetration of the chemical into the deeper zones where the SRB, that is the main cause of H2S generation, is growing rapidly. We have also initiated the line flushing between the interconnecting pipeline of the ATP and WIP, where the persistent biofilms are available, which causes the recontamination of water. And most important part was the consistency and the monitoring. So we have adopted the revised dosing strategy after observing the prolonged failures in the dosing strategy. Since we could not able to arrest the growth completely, so we have adopted the revised dosing strategy. In this dosing, in the ATP one, we have initiated the shock dosing once in 15 days, and that is a 200 liters of the alternate biocides, and the regular dosing of 2 liters per day. And here we have also kept the surge tank into the isolation for 3 days. It was done for maximizing the contact time of the biocide. And when the water was transferred to subsequently to the WIP1, here we have initiated only the shock dosing once in a week. That is approx 160 liters. In the ETP2, due to the design constraint, we could not isolate the surge tank. So here we have only adopted the shock dosing once in a week and the regular dosing per day. So here we have adopted the shock dosing once in a week, that is 50 liters of alternate biocide, aldehyde and amine, and the maintenance dosing of 6 liters per day. We have also observed one thing, that in the ATP outlet, although the GAB and SRB was found nil, although unexpected rise of microbial count was observed at the WIP inlet, which indicate that there are some persistent biofilms are available within the interconnecting pipeline, which facilitating the recontamination during the water transfer. So we have initiated the line flushing once in a month by using the biocide and sodium hypochlorite to remove the available persistent biofilms in the pipeline. Here the sodium hypochlorite also plays an important role to neutralize the microorganisms and to reduce their count, and it works as the oxidizing disinfectant. So these graphs shows the results. As we can see, before we have adopted the revised dosing strategy in the month of April or May or April. Before that, the GAB and SRB was constantly high. I have showed the data of a few months here for the reference only. So in the June, we got the breakthrough, and all the units of both the ATPs and WIPs got nil GAB and SRB. However, due to the dosing lapses in the month of August, SRB was reappeared, although GAB was still within the limit. So after restoring the dosing, again in the month of October, we could able to achieve the nil GAB SRB, and subsequently from revised dosing strategy, we are achieving the nil GAB and SRB constantly. This data shows the GAB and SRB for the ATP and WIP 2. Now let us discuss about the SP pilot project. See, it is actually an important project for us since it is the tertiary, it is implemented for the tertiary crude oil recovery. So here we have started the dosing in the raw water tank. So in the raw water tank, we have started the biocide dosing to arrest the growth, and we could able to achieve the nil GAB and SRB. However, in the soft water. Soft water is the water which is being used to prepare the SP slug. However, still the SP in the SP slug outlet, the SRB was still found. So it indicated that there is between the soft water tank and the final slug outlet, somewhere the biocide films are still available. So we have initiated the dosing in one of the tank, that was the polymer maturation tank. It was just before the SP slug outlet, and we could able to arrest the growth of both the bacteria. So these are the results which I have already discussed. Now the slide highlights the key findings on the microbial control in the oil field operations. First one is that using a rotational biocide strategy was more effective, and it has prevented the microbial adaptation and resistance. And the second one is that biofilm the presence of biofilm were the main source of recontamination, and oxidizing the line flushing helped us to remove them. Also, the consistent dosing was essential. Any interruption led to the quick bacterial regrowth, and this integrated strategy will help us to is expected to improve the overall asset integrity by reducing the H2S generation. Thank you for your time and listening. Thank you.
Thank you for finishing the presentation on time and giving different insights that we should not lose sight of the microbes which are present in our water systems, because they can lead to formation of H2S and then ultimately corrode the infrastructure. Thank you. I will take the last speaker, Mr. Shathish Kumar, who is a Joint Director in OISD, Oil Industry Safety Directorate. And he will speak on comprehensive analysis of several incidents that have occurred in Indian refineries and gas processing plants, focusing on their root causes and the management system deficiencies.
Thank you, sir. Good afternoon, all. For the next few minutes, we are going to talk few significant learnings from the accidents which has happened in the recent past in our Indian oil and gas industry. So that we can enhance our safety in our industry. So always there is a saying, right? Learn mistakes from other incidents. Don't wait till the accidents is happening in our location. So with these few words, let me go into the presentation. So my topic is enhancing safety in Indian oil and gas industry from the recent incidents. Before getting to my presentation, let me give a few insights about OSD. That is the Oil Industry Safety Directorate. So, in view of the catastrophic incidents which has happened in 1980s, precisely in 1983 and 84, there are a few incidences happened in our Indian industries. So, because of that, Government of India has set up a Safety Council in 1986 under the administrative control of MOPNG. Hence, OSD has been established as a technical directorate under MOPNG to assist Safety Council and to oversee implementation of all the decisions which has been taken in the Safety Council. So our objective is that enhancing safety of oil and gas industry. So OSD jurisdiction there are exploration and production installations, refineries, petrochemical plants, gas processing plants, pipelines, product other than LPG installations, and LPG installations are coming under the jurisdiction of OSD. And OSD is the competent authority for overseeing offshore E&P safety. So that is, we are the regulators in offshore industries. And of course, OSD is having an MOU with few institutions and organizations to establish and foster a constructive relationship. We have an MOU with American Petroleum Institute, Center of Chemical Process Safety, and Center of Hydrogen Safety also. So this slide tells about the overall functions of Oil Industry Safety Directorate. We formulate standards in association with industry members from various organizations. So we have total approximately, we have 108 numbers of standards. We are having a standards in the areas of design, operation, maintenance. If you name any profile, we have the standards. Like already we are having an explicit standard of hydrogen standard also. And presently, we are in the formulation of developing major 3 standards in the area of ethanol handling, compressed biogas, and road safety also. Because in the recent past, if you see, there are a lot of road safety accidents has happened. So based on the directive from the ministry, we are developing the standard for road safety also. So of course, after completion of the OSD standards, so we do carry out external safety audits at the defined frequency. And based on the recent incidents which has happened in Bagajon incident and Cyclone Taute, so we do carry out organization audits to see how the corporate level observations and recommendations is being percolated to the down the level entity level also. So, and of course, in the knowledge sharing front, we do carry out a lot of seminars and workshops right from senior executives to the field staff. And we do carry out accident investigations. So from there, so that we can mitigate the recurrence of the incidents. And of course, as a regulator, we are the regulator to consent to, we provide a consent to operate in the exploration and production, that is in offshore installations. So let me go to the core area of my presentation. So there are 3 case studies. Of course, 2 case studies, because one has been explicitly covered by my previous speaker, that is the fire and benzene tank. So I'm going to cover fire and crude unit and fire and gas compression unit. So let me go to the first case study. This case study has happened during the startup of atmospheric vacuum unit. So after completion of M&I, so they have, in the process of cold circulation and hot circulation, this incident has occurred. Because of this incident, 9 people got injured. So during the startup, of course, many people will be there, but unfortunately or fortunately, around 26 people were present near to that silencer. So because of that, 9 people also got injured because of this incident. Generally, if you see in the newer configuration, the MP steam will be taken directly from the battery limit and we will fade into the respective columns and strippers. Since it is an older configuration, the MP steam was taken to the furnace after preheating the MP steam to the required temperature, that is here in this case around 320 degree. So after attaining the superheated temperature, the steam will be diverted into the respective columns from this diversion valve. So till we attain the superheated temperature, we will be venting into the silencer. So if you see, from the diversion valve to the respective, the C3 column, the pipeline is around 20 meter and approximately 1.4 kL of naphtha was accumulated in this respective loop because of the passing of the multiple block walls. You won't believe me, around 5 to 6 block walls and 1 non-return wall was passing. And of course, there was no pressure transmitter was exist. The wrong valve was opened first. Normally, during the introduction of stripping steam, we will ensure there is no hydrocarbon was present in the stripping steam header by opening this LPD. Unfortunately, in this case, this was not done. So instead, they have opened the diversion valve first. Because of the diversion valve, the opening, the cold naphtha, the naphtha was at around 110 degree temperature, and the steam was around 320 degree temperature. Once the diversion valve was opened, the 320 degree steam was getting contacted into 110 degree naphtha. As you are aware, the liquid naphtha vapor expansion ratio is around 1:250. So once the steam was contacted in naphtha, the naphtha got expanded into multiple times, into 1:250 times, and it has come to the nearest possible pathway, that is the silencer. So from the silencer, the naphtha got spilled out, and because of the auto ignition temperature, the fire has happened. So of course, the root cause, as I told, the accumulation of naphtha in the stripping steam header is a major root cause. And why the fire has happened? Because of the auto ignition of heavy naphtha. So the major recommendation is that in this case, the introduction of stripping steam, that is the SOP was not properly covered. Which one has to, the block valve has to be opened first, to which column or to which stripper it has to be routed first, that was not explicitly covered. So we have told to SOP to develop accordingly. And the operating parameters are not strictly adhered, because if you see during the startup for this strippers and columns and all, they himself has mentioned that 60% of the level has to be mentioned. But in this case, around 100% of level was there for more than 24 hours. And the pre-startup safety review shall be strictly complied, because in spite of the non-completion of many jobs like open manholes and the non-completion of firefighting facilities and few scaffolding and scrap material, in spite of that, the pre-startup safety clearance was issued. So we have told pre-startup safety review shall be strictly compliant and ensure that there is minimal manpower during critical activities, especially startup and shutdown. So these are the major recommendations which has been arised from this atmospheric unit incident. And coming to my next incident, this incident has happened in one of the gas compression unit. Generally, the gases under the two-phase flow will be taken from the offshore to the crude stabilization unit, that is the high pressure separator. From there, the stripped off gas will be coming to the second stage compression unit. So from the incident has happened in this compression unit. So the incident is like in the second stage discharge volume bottle, there is a 1-inch drain line. So because of the excessive vibration, the 1-inch drain line got snapped off from the position, and because of that, the gas has come out. So if you see, the left side is the as-built P&ID and the right side is the isometric diagram. If you concentrate on the second stage discharge volume bottle, there is a drain line, 1-inch drain line with a block wall with the end cap. That is the as-built P&ID denotes. But if you see in field and isometric drawing, that 1-inch drain line made downstream, they have extended with a 2-inch drain line. That extended portion has been given to the oil water separator, that is OWS. But this change was done without MOC, that is management of change. In fact, there was a hydrocarbon detector was located near to the compressor area, and you will not believe me, during the 9 hours period, around 546 times the hydrocarbon detector got activated in 9 hours time. But all the alarms was unattended. Had it been the DCS panel operator was aware, this incident would have been averted. And significant gas flow rate drop also was there, which also went unattended. And persistent vibration and knocking sounds. Because during the routine surveillance, the operators has noted the vibration and knocking sound, but that was not properly escalated to the concerned people to mitigate that one. And physical verification of drain line was not in line with the P&ID, as I told in the previous slide, and the drain line was modified without management of change. Of course, they have done the thickness measurement for the suction and discharge volume bottles, but not for the drain lines, because there was no practice of small bore piping inspection. And that, though they have extended the 1-inch line to 2-inch line, the appropriate supports was not provided in the extended drain line, and no practice of small bore piping inspection. And the major observation is that there was, since it is an older compressor, there was no in situ vibration probe was there, and there was no practice also of physical vibration also was not there. And because before the incident, 1 or 2 years back, they have increased the suction and discharge volume bottle capacity, they have increased to 30%. Because of the weight in reduction, means weight in increment, there was no pulsation study was carried out post replacement of the compressor. And no mention of vibration, because the vibration issues was never escalated in any of the safety committee meetings or in their apex meetings. So the root cause is because of the excessive vibration monitoring, the 1-inch drain line got snapped off from the position, and there was no continuity jumpers also was there. And how the fire has happened because of the metal to metal friction after snapped off from the original position. So the major recommendations, these are the major recommendations. Whenever you are replacing or whenever you are augmenting your capacity, the pulsation and vibration study for the compressor shall be conducted, and appropriate pipeline supports has to be provided for all the modifications. Comprehensive inspection plan, especially for the small bore piping, has to be provided. And this is a major one, this timely response by the panel officers whenever any alarms, whether it is process alarm or the fire and gas detector alarm has to be is there. And management of change shall be followed for any modifications. And in situ probes or physical vibration monitoring shall be followed. I'm going to skip this one because already it has been covered by my previous speaker. So this slide shows the statistics of incidents which has happened in the Indian oil and gas industry. If you see, this statistics is for 5 years. If you see, year on year, the numbers is keep on increasing. Because from 2024, if you see, there are 13 incidents. 2025, there are 14 incidents. It shows that it is keep on increasing. So this slide depicts the root cause analysis for the incidents which has happened for the last 5 years. If you see, 32% of incidents has happened just because of inadequate work procedure or disregards of SOP, followed by 15% contributes to inadequate competence, and followed by 12% contributes inadequate HERA and all. So are we really learning from the mistakes? If you see from 2015 to 2020, Based on this inadequate competence, there are 9 incidents happened in 2015 to 2020. And if you see in 2025, there are 12. So likewise, if you see the disregards of SOP root cause, there were 17 incidents happened in 15-20, but if you see in 2025, there are 30 incidents. So what it implies? So the horizontal deployment of the incident recommendations is missing to the greater extent. So the classic example is shown in this slide. If you see, because of the improper vibration monitoring, one incident has happened in 2020 in one location, that is in Refinery. But if you see in 2025 also, the same root cause, the same incident is happening in elsewhere locations. In this case, it is a gas processing plant. So the major incidents are happening because of this so activities, especially the startup shutdown, tank sampling, and during excavation and hard work permit and all. So what is missing? So sense of vulnerability is missing. So one cannot think that the incident cannot happen to me, though we are equipped with adequate systems, procedures and all. So the incidents can happen to anyone. So we should be more relying on our calculative safety or the proactive safety, but not the reactive safety. So the path forward should be, we have to improve our safety culture, we have to improve our competency assurance of employees, and so on. So I'm going to tell 10 elements which can significantly improve your safety compliance. That is, one is leadership management and commitment, robust safety management system, appropriate training to the employees and contract employees, and contract safety management strategies, and the importance of work permit system. And the most important element is asset integrity of your static equipments. And the 7th element is like emergency preparedness and response, compliance monitoring and audits, digital technology adoption, and the continuous improvement. So I can assure you that if you follow or if you strengthen your 10 elements of the safety management system, definitely you can increase your safety compliance in your industry to the greater extent. Thank you.
Thank you for the insightful presentation. Overall, all the speakers have spoken on different areas of related to safety and given key learnings what they have learned out of their experiences while dealing with those issues. Thank you all.